I'm Carlos, work for ITV as a core software engineer. I'll be talking today about distributed tracing and metric collections for Scala. Just a brief summary of what I'm going to say today. We'll be mostly looking at an open source library called Kamon, which allows you to do much of this distributed tracing and metric collection. We'll then look at a small project I've built to essentially show off some of the capabilities and some of the value of Kamon. I'll just show you the project running for a brief moment, and then we're going to go into understanding how Kamon can help you have monitoring, alerting, and tracing in your applications. And then I'm just going to give you a quick overview of how you can use, how you can integrate Kamon within your project. So Kamon is an open source library. It supports most of the open source frameworks we use nowadays for Scala. So it supports HTTP4S, Play, HTTP. It has some modules for dealing with futures, for collecting data associated with JDBC or system metrics. And it's kind of funky in the end, but whatever. And it also supports exporting that data in various formats. So you can export it as a Prometheus to InfluxDB, StatsD, or there's other integrations as well. So foobar is essentially my attempt to model a fully automated pub or a fully automated bar. The way it works is quite simple. A user comes in, they fire an HTTP request to a console application, which will take that request, forward it to a bartender app, and the bartender app will essentially publish an event into a RabbitMQ instance saying, there's a new request for a specific drink. On the other end of Rabbit, we'll have different types of taps, each of them for a specific drink, and they'll essentially pick this event and pour a drink. In this case, it will only sleep for a couple seconds or milliseconds, but that's what it does. After that, each tap will publish an event saying, this drink has now been poured. That will get picked up by the bartender, which will update the console app, which will, at any point, the client can check if their drink is ready or not. And at some point, it will be. So let's just see this thing working. So essentially what we have here is there's a set of services running in the background. And we can see that if we fire an HTTP request saying, I want a drink, and the drink is water, we'll see a couple of logs of this entire flow being implemented. So very briefly, I'm just going to start here a small script. What this is going to do is essentially start requesting randomly water, soda, and Coke drinks with parallelization level of 3, so 3 at a time. And you can see the logs start appearing. And the question now is, imagine this is a production system. How do we know if our system is actually healthy or not? So we could just say that it's responding to requests, so it's up. But that's maybe not enough, because we may want to know if it's responding to, maybe it's failing for a specific type of request, maybe it's taking too long for some requests. And so the way Kamon allows you to deal with that, or that helps you to deal with that, is that while your service is running, Kamon will be gathering metrics and gathering data about how your service is running. And we'll then publish that data to some outside tool where you can store it and you can visualize it. In this particular case, I've hooked up my services to publish to a local InfluxDB instance. And then I also have a Grafana dashboard on top of that. So what we can have with that is, so you can see that we have multiple dashboards created, one for each type of application. And we can see, like, for instance, for the console application, we can see request throughput, we can see response times, a status code count. What else? We can see, because our application is calling other applications, we can also see how long is it taking to call those specific applications, what kind of status codes we're getting. We can see query times to the database, JVM metrics, so JVM memory usage, threads, and so on. And another very interesting thing is that we can break it down by specific endpoints. So we can see for a specific endpoint, how's it going? Is it returning errors, or is it not returning? So then with this, you may, we now are able to more or less assess if our application is doing fine or not. But there's still a component of alerting that we haven't dealt with. In that case, Kamon doesn't really help you much. But we can actually, having Grafana and having all the data in InfluxDB, we can easily hook up something to one of those applications and create thresholds and conditions that, if broken, they will alert us. And in the case, once we get alerted and we have to go in and try to understand what the hell went wrong, one of the things that will help us is having all of this data of the performance, of the load on our application, which will maybe help us debug what went wrong. But there's also a case to be made about being able to see things in the logs, or to be able to visualize what actually happened in our application. And that's where tracing comes in. Before we go into see what Kamon does in terms of tracing, I would just like to introduce the span, trace, and context concept. In a simple way, the trace and span you can see as identifiers. So a trace identifier will be a unique ID that will identify an execution throughout your entire, distributed execution throughout different services. And then within each service, you associate that with a span identifier. And then associated with that span, you usually create a context which will hold information that's valuable for you to understand that specific span. So a quick example would be if we have two services, A and B, and during A execution, A calls B twice. That would mean that service A will create a trace ID and a span identifier, identifying the trace, identifying this entire distributed call, and the span will identify the call in service A. And then if we're talking about HTTP, we'll probably associate a context which can hold the URL that was called, the status code that was returned, like begin and end timestamps, and so on. So then service A calls service B, sends along a trace and the span ID, mostly because service B has to know that it's being called within this specific trace. Notice that the context is not sent through the wire. Usually this is done using the HTTP headers, but it can be done in various ways. And so when service B starts processing the requests, it will generate its own identifier, which will essentially identify the execution of service B and its own context, again, giving us more knowledge about how service B, what happened in service B. And then for the second call, notice that trace ID and span ID are the ones that are sent are exactly the same, because we're still in the same distributed call, and we're still, the span identifier is still the same. And now service B will create a new span identifier, identifying this new execution and a new context as well. And so in terms of tracing, what Kamon allows us to do and what it helps us with is when your service starts executing, it extracts all of this information, these trace identifiers and these span identifiers from the HTTP packages, or you can even integrate it with RabbitMQ or whatever communication layer you're using. And it takes that and it propagates it through your call stack within your service. So at any point, you can access trace identifiers, you can access the span identifiers, and so on. And it also helps you propagate it when you make external calls from your service. And what that gives us is, so for instance, let's say we're interested in, let's say, this specific request, just as an example. We can then go to our logs And, oops, that was wrong. Why did it? And we can find something that makes sense to us that was like mainly related with the request we're interested. And you'll notice that Kamon is injecting a trace ID into the logs. So now we can isolate all the logs that were generated for that specific call. So at this point, it's not. OK. So you can see that this is only log lines that were generated during that specific HTTP request across all of our services. And in this case, there's not that many logs. But if we wanted to further restrict our domain of logs, we can use the span ID to restrict it down to a single service. One thing that I didn't mention is that the span identifier can be arbitrary. So it could be associated with a single function, or even like you could just look at a specific part of your services. And then if you get to integrate this with tools like Jaeger or Zipkin, you get a very nice visualization of what happened in your service. So this is not the best trace. This one's a bit better. So we can see on the right, we have our services. We have the duration of each individual request. And we can see, for instance, in this case, that there was a bit of an error here. This is not 100% obvious, but if you look closely, you can see that there's two queries being executed at this point. One of them is an update for this specific identifier, and the other one is an insert for the same identifier. So we can kind of see that there's some kind of race condition going on, where the insert and the update are being issued more or less at the same time, meaning that we have an error because we're trying to update something that doesn't exist. This kind of analysis I'm not going to say it's obvious, but it's way easier if you have this kind of visualization. And this is also very good if you want to do optimization analysis, because you can see exactly where time is being spent and where you should go and try to fix and try to improve performance. And yeah, lastly, in terms of integrating things with Kamon, integrating your projects with Kamon, the most changes you have to do are based around build SPT, plugins SPT. So it's mostly configuration, so you have to add the libraries and add some plugins. And then the main code you actually have to write is essentially a way to take an URL and make it into a generic identifier. So essentially to deal with things like if you have an URL which is /client/client ID, you have to provide Kamon with a way to turn that into a unique identifier so that it can then group them by operation rather than by individual URL. And then depending on the framework we're using, for instance, for Play and HTTP, there's not much to do because it is essentially based on aspects. So you won't have to do many changes to your code. But in this particular case, this application is running with HTTP4S and CATS effects. And in that particular case, what we essentially have to do is provide it with just wrap the client and server instances and provide it with a slightly tweaked execution context so that it can do the propagation on its own. And so, yeah. Lastly, so this is the repository, which holds all the code that I've just shown you. You should be able to run this just using Docker and Docker Compose. So it has all the Grafana, InfluxDB, all of that is here. So yeah, you can check it out. You can do, and everything should be there. There's also, if you look closely, there's a commit where I put most of the code changes needed to go from Kamon to go from a regular project to a project with Kamon. And you can see that most of it, this is split across 3 different services. But if you look at it, it's mostly configuration and a couple of changes at the main level. the last thing I would like to reference is even if Kamon doesn't support a specific integration, like I had, for instance, the RabbitMQ client library I'm using, it's one that's developed at ITV, it's an open source project, which doesn't have an official Kamon integration. And I actually built my own, which is just this 100 lines of code. So it's fairly easy to do as well and to integrate with. Done.